The Starch Test, testing for the hydrolysis of starch. To begin the starch test, you will need an agar plate supplemented with starch, the bacteria with which you are going to inoculate it, and a Bunsen burner and loop. Begin by drawing a line down the center of your plate and then labeling each side of the plate with the bacteria you are going to use to inoculate it. You will use aseptic technique to draw a straight line inoculation on the surface of the agar. Starch hydrolysis is the breakdown of the different forms of starch found in the environment. Bacteria can produce several different forms of enzymes used for the breakdown of starch. The enzyme we will be testing for is amylase. Amylase is used to break down a form of starch known as amylose. Amylose is a simple or linear starch found in breads, grains, fruits, and other foods. A second form of starch often found in combination with amylose is amylopectin. Amylopectin is a complex starch, also known as a branched starch. Although amylase may be able to somewhat break down amylopectin, usually a second enzyme known as oligo-1,6-glucosidase is used to break down amylopectin into a linear form, which is then further broken down by the amylase. Shown here is a simple diagram highlighting the differences between amylose and amylopectin. As you can notice, amylose is linear. It uses an alpha-1,4 glycosidic bond. Amylopectin, on the other hand, is linear and has the addition of branches. The linear portion of amylopectin uses the alpha-1,4 glycosidic bond, just like amylose. However, the branches are created when alpha-1,6 glycosidic bonds are used. Interpretation of results: the addition of the iodine reagent. After incubation, your starch plate with the bacteria growing on it will be flooded with iodine. When iodine comes into contact with starch, the starch will turn a dark purple or black color. If an organism produces the enzyme amylase, the amylase will be excreted out of the bacteria and into the agar, where it then diffuses. As the amylase diffuses through the agar, it will break down any starch it comes into contact with. As you can see here, the organism on the right produced amylase. This causes the clearing or halo seen in the agar after the addition of iodine. The organism on the left did not produce amylase, so the starch is still present in the media surrounding the organism. The reaction between iodine and starch is immediate. This makes the starch test a very simple one to interpret. After flooding the plate with iodine, it only needs to sit for 30 seconds to 1 minute in order for results to be interpreted. Most of the time, results are visible before you've even completed flooding the plate with iodine. Shown here on the left is an organism positive for the production of amylase. On the right, the organism is negative. Starch hydrolysis, or the starch test, is a simple and easy test used for the identification of many gram-positive organisms. However, some gram-negative organisms may also be positive for amylase production or starch hydrolysis.